on this, let me know where the hard ones are, or because I don't want to miss things. Okay, so y equals x plus 7 over x plus 9. So they're going to basically ask you a bunch of questions you already know how to do. We just did in the last section. They're going to say, what's the domain? Remember what we've learned about for domain? Domain, you just take denominator cannot be 0, right? So just x plus 9 cannot be 0. So that means x cannot be 0 or negative 9. Right there, there's that. And then they say, okay, what's the equation? So I'm on to part B now. Vertical asymptotes. Well, vertical asymptotes are denominators, are the same thing, right? So it's x times x plus 9 equals 0 instead of not equal 0, but basically the same thing. So again, it's 0 and negative 9 right there. There's the verticals. Horizontal, as we just covered. So the horizontal asymptotes, we'll do those, the powers on the top and the bottom, right? The numerator power is 1. The denominator power is 2, guys. Maybe I should explain that. You have to multiply out. We're talking like if it was multiplied out. So, right, because this, yeah, maybe I better show that. So the y equals x plus 7 over x plus 9. Yet, really, if you FOILed out the bottom, boom, boom, you'd get x squared plus 9x. So really, that's a first power on the top and a second power on the bottom, isn't it? That's really what it is, even though it was given to us in factored form to begin with. The numerator power is 1, the denominator is 2. So if the denominator wins, it flattens it out to be y equals 0. That's why I wrote y equals 0 for the horizontal. So we good with all those facts? Mm-hmm. So with all those facts in mind now, okay, so think about what we know so far. We know the vertical asymptotes are at 0 and negative 9. 0. So negative 9 and 0. We have vertical asymptotes, and we have a horizontal asymptote at 0. Like that. So we know those are the asymptotes for the graph. Now, what do we know beyond that? Not much. Not much. So you can hit the buttons on your graphing calculator. At this point, I would type it into my graphing calculator, put in y1 equals x plus 7 over x plus 9. Hit the graph button on your graphing calculator, and you can figure out which of those graphs is actually the right graph. I think we could eliminate, well, I don't know what we can eliminate. Yeah, they all look sort of right. They all have the right asymptotes, don't they?
Yeah.
Yeah, so you'd have to graph it here. I'll graph it too. Just type that into your graphing calculator. See if you can get the picture there. So what is it, x plus 7? So, here, I'll show it as well. If you have, like I do, the older kind of calculator, yeah, you know, if you have the new kind that shows it as a nice fraction like that, then great. It just do that and it's all good. But if you have the older kind like I do that lays it all flat on one line, then you have to put parentheses around the numerator and the denominator. Divided by, you got a parenthesis, x, an extra parenthesis like that. If it's all flat, that is. If you're of the old style that lays it all flat, you got to type it in like that. Parentheses around the numerator and the denominator separately. Otherwise, it won't know what's what. Whoops, I did the wrong thing. And my window. Always check your window. Negative 10, positive 10. Or no, they tell me the window, aren't they? Yeah. Yeah, for the window, just look at what they're doing. What does it look like they're doing? They're going on the x, negative 16 to, I don't know what, 4, 5, 6. So negative 16 to 6, how about? For the x, negative 16 to 6. That's what I'm seeing there. Just looking at the graph. Negative 16 to about 6. See, they go a little past 4. Looks like 6. Okay, and the y goes from what? Negative
Negative 5,
5 to positive 5. Yeah, the y is negative 5 to positive 5. Everybody see that? On their graphs, you know what I mean? The y is negative 5 to positive 5 and negative 16 to like positive 6, it looks like. I'm just looking at what they did. You know, that's how you should do it on a multiple choice. So do that, hit the graph button. I'm doing it right now as well. Let's get turn the thing on there. There's what I got. So is that what it is? Is it? Yeah, it looks like B, doesn't it?
Yeah.
Yep, looks to me like B. Y'all good? You guys getting that on your screen? If you have any trouble, grab me after. Be glad to help. But yeah, I'm getting on my screen B. So so what we're seeing here is an agreement between the facts we find by hand, vertical and horizontal asymptotes, and what technology does for us as well. Hand in hand in glove. It's part of what we want to learn, you know, in this class is how technology and by hand work together. All right. So some of these get pretty tricky factoring. Okay. So let me do that with you. 28x squared minus 29x minus 35 over 4x squared minus 31x plus 42. Yeah, this is bad factoring. I'm glad to help you with all this. Come see me. You do need to learn to factor this kind of stuff to move on into, you know, into calc and be successful. So how do you factor? Well, I do the little FOIL thing, and I just ask myself what works, you know. Front times front to be 28x squared. 7x, 4x. Probably. Could be 2 and 14. How do you know whether to do 2 and 14 or 1 and 28? How do you know it's 4 and 7? Well, it could be, but it's usually the numbers closer together. Have I talked about that? When you have options, when you're looking at 28 and you're thinking, is it 4 times 7 or 2 times 14 or 1 times 28? It's probably the 4, 7. It's probably the numbers closer together. They're only 3 apart instead of, you know, 2 and 14 or 12 apart. So try those two, 4 and 7. Now, 35, what times what's 35? 5 times 7. The 7 can't be here with the 7.
No.
So probably the 5 is here and the 7's there. It's probably what it is. Now, how do you know if that's right? You basically just FOIL it out and see if it's right. I mean, that's basically it. You just say, okay, let me see. Boom, boom, what's that? 28x squared, and I don't know what the sign. Let me just make them both plus, and I'll fix them in a minute. Plus 49x, and then boom, boom, plus 20x plus 35. Is that right? Can these guys make the middle minus 29? Yeah, if I make that 49 negative, then minus 49 plus 20 will be minus 20. So make that 49 negative. And the 35 is supposed to be negative as well. So how do you make the 49 and the 35 negative? I don't know. I think you make the 7 negative. Wouldn't that do it? Yeah, because that'd make the back 2. No, is that right? Did I do that right? Yeah. That's right. That makes the 49 negative, and that makes the 35 negative. That's right. So it's right. So I'm just fiddling with it till it's right. Does that make sense? That's what you got to do. Just do the FOIL until it works. Now the bottom, same kind of thing. I'm thinking FOIL. So I'm thinking 2 parentheses, 2x probably, but maybe for the 4x squared it's 4x times 1x. I don't know. I'm going to try the 2x and see. 42, what times what is 42? Could be 6 times 7. 6 times 7 maybe. Could it be 6 times 7? No. Can you have a 2 and a 6 in the same parenthesis? Not allowed. They'd have 2 in common, right? You can't have anything in common. Why not? Because you get the commonness out in the beginning. If there was something common, I would take it out right in the beginning. Like if 4, 31, and 40, if there was some number that went into all of them, I would do that right in the beginning. So there'd be no commonness there. So it can't be 6 and 7. Well, what else multiplies to be 42? I don't know, 3 and 14, I think? 30, 12, yeah. Can it be 3 and 14? Oh, wait. No, because again, the 14 couldn't be in either spot because 2 and 14 would have something in common. Yeah, so it's probably not 2x, 2x. It's probably not. It's probably 4x and x this time. Let's go back now to make the 42 is 6 times 7. Again, the 6 cannot be there because 4 and 6 would have 2 in common.
4 times.
So 7 could be here and 6 there. Let's make them both plus and see what happens. I'll fix the signs later. 4x squared plus 24x plus 7x plus 42. What do these two in the middle make? 31. Yeah, but it's supposed to be negative 31.
Which means they both have to be negative.
So they're both negative. You make them both negative. Now try it again, and this will be negative 24, negative 7x, and the back is still plus 42. That's minus 31x in the middle. That's right. So that's it. You just got to foil so often, so many times, so much practice to where you can get it right. It's got to be 100% right. Okay, so with all that said and done, notice what happens. This is the kind. That's why I spent time on this one. See what's happening? Cancel. So in the end, it's 7x plus 5 over x minus 6. You with me? After reduction? Okay, so I have something important to say now. I mean, it's not the end of the world, but it is something I bet you're not aware of. So am I doing the Charlie Brown teacher voice? Dial in. If I'm doing wah, 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 dial in for a minute to the radio station here. Catch this. This matters. Domain, I still have to deal with both of those. But vertical asymptotes, I don't. That might seem really strange at first. Let me say that again and write it down. So, domain, denominator, denominator not equal to 0 kind of thing, before canceling. You got to do the domain. What did I spell there? Like a ceiling. Before canceling. Yeah, that's right. It just looked weird. Before canceling. Before you cancel anything. Why? You think they're out of there. 4x minus 7's out of there. Well, I know we cancel in algebra, we cancel and stuff, and we sort of can, but really it's there. I mean, really it's there. Really it's there. Even though we cancel it, it's really there. So anything that makes that any x value you plug in that makes that piece 0 is really going to choke the function. It's really a problem. So you do the domain 0 thing before, the denominator 0 thing for domain, before canceling. So you take the 4x minus 7, 0, even though he's going to cancel out in a minute, and the x minus, and then you just solve them both. They're both part of the story. 4x is 7, or can't equal 7/4, and can't equal 6. So cannot equal 0, cannot equal 6 or 7/4. There it is, option C. Does that make sense? But the very next step, I'm going to do vertical, and vertical is almost identical to domain, but here's the one difference. You do the vertical after canceling. Because that's not going to really be a vertical asymptote, because it does drop out. But it's a trouble spot on the graph, because it's technically there, going to make the bottom 0. But it won't really be a vertical, because it's going to drop out. So when I go to vertical next, you do denominator, almost the same, denominator 0, but after canceling. So verticals are after canceling. Domain, anything that was ever there at any point in time that would make that bottom 0 is a problem for domain. Everything else, normal. Hey, it canceled. So for the vertical, we're like, hey, it canceled. Just grab the x minus 6. So it's just x equals 6 for the vertical. Does everybody see that difference? Small little detail there. The rest is the same, Do the horizontal, do the graphing calculator, blah, blah, blah. Is that okay? Did I just say blah, blah, blah and move on? Good there. What would be the horizontal? Can you guys just look at it and tell me? What's the horizontal on this one? Remember, all you care about, highest power on the top, highest power on the bottom.
So
28x squared over 4x squared for the horizontal. These cancel.
Yeah, cancel.
7. Y is 7. Done. Right? Same power. The numerator and denominator power are equal. They cancel. Just a over b, 28 over 4, 7. Y equals 7. for the horizontal. And then do the rest in your graphic calculator. The trick on this one is they've separated. They're trying to give you different looks now. This is a lot of what you need to practice to master, math classes, science classes. Is you want to notice this is a different format. It's different
Same.
because it's not one fraction.
Oh.
So make it one fraction. Do you see what I mean? All that we're doing, numerator, denominator, vertical, and all that stuff, it must be one fraction. Look back. See, this is one fraction. Not a fraction and then something added. Right? One fraction. One fraction. You get the pattern, right?
Uh-huh.
So that's the kind of thing that you really have to spend time on in math science classes, recognizing the form. That's a lot of the battle, because when you get the exam in a couple of weeks, you want to look at it and go, oh, that one's one fraction, that one's separate. I got to, the recognition. So when you see this, you go, oh no, before I do any of my vertical, horizontal stuff, I got to put them together and make them one fraction. So how do you do that? We have x plus 1 over x. Well, anytime a whole number or a whole letter is interacting with a fraction, you put it over 1, make it look like a fraction. Now, how am I going to combine those into one fraction? Common denominator, huh? Top and bottom by x. So this will become x squared over x plus 1 over x, which is x squared plus 1 over x.
Huh.
Did you track with all that?
Uh-huh.
I made it into one fraction. Now, I can see where that would be confusing, because you might think, Mr. Heron, about an hour ago, you had one that was like this, and you broke it into two. Yeah, that was for a different purpose. So basically, it sort of just depends on what you're trying to do at the moment. If somebody was asking me, yeah, I did it in the last section because I knew that when I broke it up, it would be easily recognizable. Remember, it was one of those, what was it? It ended up breaking up, and it became something we recognized where like it had a 5 plus 1 over x squared or something like that after we broke it up. Because then I went, oh yeah, it's just an x squared, 1 over x squared graph with the two branches up, then the 5, so it's been moved up. It just, because my goal at that time was to get it in a format I could recognize. My goal on this problem is to make it one fraction. Why? Because I'm doing domain, vertical, and horizontal asymptotes. For what you need one fraction for vertical and horizontal asymptotes. That's really the story. All the rules I just gave you for vertical and horizontal asymptotes, the methods I gave you, all depend upon you having one fraction. Right? I said denominator this, numerator that, and right? So you got to have one fraction to analyze that. So is everybody seeing that difference? So it sort of depends on what you're trying to do. If you're trying to find vertical and horizontal asymptotes, you got to make that thing one fraction. If you're trying to recognize what it looks like, for maybe a graphing question on part 1 of the test where you don't have your graphing calculator, then yeah, you probably got to break it up to get it till you can recognize it. But I'm not doing that here. I'm just going to use my graphing calculator on this one when it comes to the actual graph, right? So there, it's one fraction. Now I can analyze vertical and horizontal asymptotes. What's the vertical asymptote? Denominator equals 0, so that's just x is 0, huh? Nothing more than that. What's the domain? X cannot be 0. Right here. X cannot be 0. So vertical asymptote, domain, right? They're all about denominator equaling 0 or not equaling 0. And can I scribble over here? Oh, no, it's not a scribble. It's a hard one. Let me come up here. What's the horizontal? Now that we have it.
X squared over x.
Yeah, what's the horizontal? Horizontal asymptote going to be?
X squared over x.
Numerator is 2, denominator is 1, right? 2 power, 1 power. When the numerator is greater than the denominator by only 1, oblique. This is going to be the slanted asymptote. right? It's not going to be horizontal. It's going to be slanted. And how do you do it? Denominator, long divide into numerator, right? Remember that? What we just did a minute ago. All right, here's a second one. Yeah, so I might have put one of these on the exam. Here's a second one. So if there's a couple, it's fair game. Okay, so long divide that. I'm going to do this quick. X squared, subtract 0, bring down the plus 1. Right? Everybody good so far? Now, all I got here is 1. Get rid of that. This is 0. So all I've got is 1. These cancel. So now, what can I put up here? Times x that'll match 1. Nothing. Nothing times x is 1. If it was 1x, then yeah, 1 would do it. But it's not 1x, it's just 1. So we're done. That's just remainder. So it's just x. X, so the horizontal asymptote is y equals x. Does that make sense? And then graphing calculator from there. So you getting the hang of this? There's a lot going on here, isn't there? We good? So if they're separate, you got to make them one fraction for doing vertical and horizontal asymptotes. It's all about one fraction. Do this without your graphing calculator. So let's do this. Yeah, I think I give you one of these. Let me help. And I'll help on review day as well. But let me help right now. All right. How can we do this without typing, it'd take a long time to type all these in the graphing calculator. And this is on part 1, I believe, with no graphing calculator. So how can you tell? Well, first off, notice the verticals. This vertical at plus 3 and at minus 3. Vertical asymptotes. Where do vertical asymptotes come from? Denominator. That means there must be an x plus 3 and an x minus 3 for the vertical in the denominator. You with me? There's got to be. And what is that? X squared minus 9, right? In the denominator. Got to be. So bye-bye. Because they have x squared plus 9. No way.
Can't do it.
Right? No. Good? Those two are out? We can flip a coin at this point. We're down to 2 options. So now, these both have x squared minus 9. They're looking good. Which of those 2 could it be? Well, I'm not sure. The only difference is one of them has a negative in the front and one doesn't. You know what I would do? You know what I'm always going to say when I come down to 2 options and I'm not sure? Make a table, plug a point or 2. Find a point that works and you'll be able to tell which is which. So let's try that. So now which point? Well, I don't know. Maybe look, I'm going to plug in 2, which looks like it's at 2. Doesn't look like 2 2's something like about 2 2's a point. I'm just looking right there. I'm just trying to find something easy. Looks like over 2 up 2 is an actual point on the true graph, right? Looks to me like 2 2 or something close to it anyway. So if x is 2, y should be about 2. So okay. So let's could it be this one? I don't know. Let's see. Minus 3x squared over x squared minus. So if I plug in 2, what am I going to get? Negative, what's that, 12 over 4 minus not, so negative 5, which is positive 2 point something, 4 I think, on your calculator. 10, 2/5, yeah, 2.4. That looks right. Pretty close. Everybody, did I do that too quick, right? 4 minus 9, negative 5, 2 negatives, positive. That looks right. I'm sure it's B. If you plugged into D, the D would have a positive out here, right? And then that would come out negative 2.4. Certainly wrong. D is wrong. B is right. You do need that extra negative in the front because that extra negative and the negative on the bottom, 2 negatives make positive 2.4. So it is indeed B. Is that okay, guys? Don't need a graphing calculator. Just find the verticals, plug in 1 point, and you can tell. Good. So that's the skills that you want to be building. Because there's the idea out there that, well, technology just does it all now. No. Technology is really stupid. It's just fast. And technology often will do crazy things. And so you have to have 1 foot of real in the world of real knowledge about what these things generally should be doing so that you can guide technology. That's how real math science works in the real world. You do have to know things, and then you can guide technology into its super fast things, but you, the one who knows the general way it should be going. Here, 7 minutes or whatever, we're going to need to do some weighty word problems. There is one of these for sure on the next exam. These are really, really important, really valuable, very, very practical. So, rectangular area adjacent to rivers, fenced in. No fence is needed on the riverside. Enclosed area is 2,000 square feet. Fencing for the side parallel to the river is $10 per foot. And fencing for the other 2 sides is $3. 4-corner post, blah, 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 blah. Let me draw you a picture. There's a river, and they're going to put some fencing, 3 pieces of fence next to a river to contain some critters. That's the plan. So the river will form one side, and the 3 fences will make a big pen for the animals. So, and then there's 4 corner posts. We want the area to be 2,000 square feet. The animals need 2,000 square feet to roam. There's different ways to do it. You know what I mean? You could make it long and short like that, or you could make it kind of more squarish. Or there's different options. There's different ways to get 2,000 square feet. There's different amounts of fencing to get 2,000 square feet. You know what I mean? You could build, well, we don't got time, but there's different options for how you build the fencing. Squarish or tall and thin or wide and short, or different ways that will allow 2,000 square feet in the middle and still, fit the fencing. So how do we do that? The fencing that is parallel to the river is $10 a foot. What's that? That's this right here. This stuff is $10 per foot. This line is parallel to the river, right? Fencing on the other side is $3 per foot. This down here also $3 per foot.
This price comparison.
Different kinds of fencing, I guess. Making sense there? That's what they're saying?
Uh-huh.
The 4 corner posts are $30 each. So each of these guys is $30, $30, $30, $30. And the question is, well, eventually we're going to start with a cost function. Eventually they're going to say build it as cheap as possible. Very, very practical. Very, very useful. It's what business, engineering does. So how do we set this up? Well, basically, let's call this X, and this Y, just to get rolling. These are the same, so I'm calling them both X. This is Y. Okay. Well, first off, let's write the cost function. So the cost will be, how about 4 times 30 for the 4 corner posts? That's $120, right?
Uh-huh.
Now, how much is this piece of fence going to cost? Well, it's $3 a foot times X feet, 3X. How much is this piece going to cost? Another 3X. How much is this going to cost? 10Y. Right? It's Y long, $10 per foot. Good for the cost function so far?
Yeah, that fits.
Let's simplify it. 120 plus 6X plus 10Y.
Uh-huh.
But notice what they say. C of X, they don't want Y. We did this before with distance ones in the last test. They want us to plug in something for that Y because they only want X in the end. So how do we do that? We use the other formula right here. Area is 2,000. You always use the second formula. Use the second. You always have 2 formulas at work in these problems. The second formula is area is length times width, right? Area for any rectangle. And what is the area? They told us 2,000. And what is the length and the width here? X and Y. So 2,000 is X times Y, right? One side times the other. Bless you. Area of a rectangle is one side times the other. So what you can do, you can solve that for Y and substitute back in the other equation. Divide by X. So Y is 2,000 over X. take that and plug it in. See how we do that?
Okay.
Come over here.
Forwards.
Okay. So what do we have? We have C is 120 plus 6x plus 10y. So that, but in the place of the y, I'm going to put 10, and then the y is 2,000 over x. That's the y, isn't it? Right here. Everybody tracking with me?
Mm-hmm.
So there, now we got to simplify that. It's 120 plus it. What do you do with the whole number? Put it over 1, goes to the top, so that's 20,000 over x. So type that in. There's your cost function right there. That's how much the fencing's going to cost depending on what you choose for x. What is x? X, remember, here's the river. Here's the river. And x is how far out we go. Y is how far the other side is, right? Remember what x is? There's different ways, there's different options for x, how we build this thing. We could make x really small and y really big, couldn't we? We could choose x bigger and y smaller. We could do it squarish, make x and y the same. Which way is going to be the cheapest? Graph that on your calculator. Graph on the calculator and find the minimum. We don't have time. I'm going to go up. We got 2 minutes. I got to set up another one with you. Graph that in your calculator and find the minimum, and you'll find the cheapest way to build that thing. We did some of that earlier, right? That's what the other parts of this question say, is find the minimum function on that. Find the minimum value for that. Okay, I'm going to move on with our last. I forgot there were these really big hard ones at the end here. So surface area. Surface area of a box is all the surface, all the sides. So see this box? It's nice to give me a picture x by y. Can everybody see that? X by y. So the bottom here, so the surface area is the bottom. What's the bottom? X squared. Right? Remember, for a rectangle, it's just one side times the other. The bottom is x squared. The top, same thing, x squared. Okay. How about the right side? What's the right side of that box? What are the two sides on the right side? X and y. What's the left side? Same thing, x, y. What's the front? Same thing, x, y. And lastly, what's the back? Same thing, x, y. 6 sides, right? 6 sides to that cube. It's not really a cube, but. And 4 of them are x, y. So you put that together, you've got 2x squared plus 4xy. There's the formula, except we don't like y. Got to plug in for y. So there must be a second formula somewhere to help us plug in for y. What's that second formula? Volume is, what's the volume? X times y. Remember, volume is the 3 sides multiplied, length, width, height. X times y. Volume, they're telling me, is 10,000. Right there. Is x squared y. Solve for y and plug it in. Divide by x squared. Boom. Plug it in right there. And so then you'll have your surface area formula. And on you go. Plug in, graph it on your calculator, find the best way to build that cube and hold the volume you need. The smallest dimensions that'll make that thing work. Very useful to UPS, FedEx, companies like that. That kind of calculation. I think.